Hi, we're going to look at changing to and from surd form, by which I mean this. Question 1. The cube root of x. That's surd form. A surd is a way of depicting an irrational number. And we're going to express it in index form. Index form means you have the symbol we're using for the unknown and a power or index. Now, it's a root, so it's 1 over something. And it's the cube root, so it's 1 over 3. If the index is a fraction, it means there's a root. I'll show you that again. Question 2. The fifth root of x is x to the 1/5. Fraction 1 over means it's a root. Now, what about if the surd itself is raised to a power? I'll give you an example. The fourth root of x cubed. Well, in index form, that's going to be x over, or x to the power, my mistake. Now, the denominator of the fraction is the root we're finding. But this time, the numerator, the top number, instead of being 1, it's going to be the power to which x is raised. If you think about it, it's part of our laziness, as I call it in maths. Strictly speaking, each of those is x to the power 1. Hence, it's 1 over 3, 1 over 5. Give you another example of that. Question 4. The seventh root of x to the power 5 equals x to the, well, because we've got roots involved, surds, we know it's going to be a fraction. The denominator is the root we're trying to find, in this case the seventh root, and the numerator is the power of x within the root symbol. Question 5. There's one other one we need to know, reciprocals. What about 1 over x squared? Well, we write that as x to the power 2. As we look, x to the power 2 here, but because it's 1 over, it's a reciprocal, we put a minus in front. So it's x to the minus 2. The minus means a reciprocal. Question 6 goes through that again. 1 over x to the power 7 equals. So we write x to the power 7, and because it's 1 over a reciprocal, we put a minus in front. Now, I've got 4 more examples to look at. What about if instead of being 1 over something, I beg your pardon, 1 under something, it's a number that x is under, the power of x is under. Yeah, I'll give you an example. 5x cubed. 5 over x cubed. We write as 5x cubed, and because x is part of the denominator, what we do is put a minus sign there. So it's 5x cubed. But what about if the denominator expression has a coefficient? Here, I'll give you an example. 3 over 7x squared equals. Well, here we treat the numbers as our coefficient. So it's going to be 3 over 7 x squared, and because x is in the denominator, we put a minus in front. So it's 3/7 x to the minus 2. Another way would be to write this. It's 3x to the minus 2 all over 7. So I think you'll find in practice when you're doing calculus, 3/7 x to the minus 2 would be the easier way to write it. Now we're just going to combine all of those for our last few examples. 8 over the square root of x. Well, We start by looking at the denominator. We've got the square root, the second root of x, so we write that's x to the half. We've got an 8 as our numerator, but because x is part of the denominator, I finish by putting a minus sign in front. And then our last one, question 10, let's combine all of these things. 7 over 5 cube root x squared. Right, let's take it slowly. Cube root of x squared I write as x. The denominator is the root we're trying to find, so it's over 3. The numerator is this 2 here, the power to which x was raised. It's part of the denominator of the term, so we put a minus in front, and then what have we got left? The coefficient, it's 7 over 5. So 7 over 5, x to the minus 2/3. Right, nothing, I repeat, nothing beats practice, so I'm going to put 11 up here. I want you to turn them to index form. Right, if you're out there trying to do, oh, hang on, let's put one more example. Right, let's copy them down, press pause, and we'll come. Okay, let's go through the answers then. Question 11. So you write x to the minus 3, it's the denominator, and put the numerator, 9, in front. Now here, we've got the 8th root of x to the power 5, so it's 8, so it's x to the denominator is 8, numerator is 5. Here, we've got, let's do the denominator, the part that contains x. We've got x to the 3/5. It's part of the denominator, so we put a minus in front and 2 in front because that's what we're multiplying by. That's the numerator in the whole term. Here, we've got, let's do the x first. We've got square root of x. It's part of the denominator, so put a minus in front. And then we had a 4 and a 9. That's the coefficient. Question 15. Doesn't really matter what order we do these in. I suppose it's more logical to do the coefficient first. So we've got 3 over 8 is the coefficient. We've got x to the power 5, and it's part of the denominator of the term, so there's a minus in front. Here, we'll adopt this approach for the second one. It's 2/5 x to the power 7. But hang on, x, we're dividing by its reciprocal part, the denominator in the term, so it's minus. Here, we've got x to the power 4th root, so my index has a denominator of 4, and the numerator of the index is 3. Here, we do, being logical now, the first thing, the coefficient is 7, and then it's x to the power 4/5. Yeah, let's again, let's get the denominator first. So it's 6 over 5. We're finding the square root. One of the things that a little bit of can be misleading. We haven't put the root. It's because it's so common. Remember, if there's no root, it's the square root. So it's going to be x to the something over 2. And the power of x within the root symbol is 3. So it's 6/5 x to 3 over 2. Now, just get rid of all the other things. It's getting a bit cluttered. Let's go through question 20. So, the first part, when I write it in index form, is 7/5, because it's 7 over 5. Square root of 4x. Before I go any further, the square root of 4 is 2. So it's the 2 square root of x. If you notice, I put a 5 there by mistake. And it should be x to the half with the minus in front. So our final answer should be 7/6 x to the minus half. Did anybody get 7/6 x to the minus half? Now the thing is, I mean, it's very unlikely it's going to happen, but if there's a square number within that, go and find that as well. Right, okay, thank you for listening. I'll probably have to adapt